less than 8.7 function notation. In 2001, a balloon like the one pictured was launched out of McMurdo Station in Antarctica. In the fourth example, you'll see how function notation can be used to explain the balloon's altitude as a function of time. Okay, the equations that you've been learning up to this point for the last couple days are in a form of y equals some kind of x plus b. Okay, that's what you've been learning up to this point. Now the big change is going to be, instead of writing it as y, it's going to be written like this. Oh boy. And what this literally means is, if I plug in specific numbers into this equation, I get this result. That's basic math, folks. 6 plus 2, the result is 8, right? F of x of 6 plus 2 is what? F of x of 6 plus 2 is 8. Okay? All this really means is the result of the numbers plugged in, and they'll give you numbers, gives you this scenario, this amount. Okay? Let me show you how it works briefly. In the equation they wrote, and this is right kind of to the left of that balloon thingy, they wrote f of x is x plus 2, okay? And if they say, what is the f of 3? Okay, what is the f value of 3? So the f value of 3 means plug a 3 in for x and solve. Obviously, the answer to this would be 5. Okay? The result when the input is 3 is 5. Okay? Input and output are a good way to describe it. X is traditionally the input, and y is traditionally the output. Some books help introduce it that way. Okay, so again, I took the equation they gave us, and they said, here's the scenario, this is the function, and what is the result of f if you plug in a 3? There's your 3. Okay? All right, let's look at example 1. I'm going to turn the page. Example 1. So let f of x, so they're giving us a function, let f of x be negative 3 times x plus 8. They want to know what f of x is when x is equal to 5. This is the first one, okay? We're going to use this scenario twice, okay, when x is 5. Okay, so we are going to plug in the value of x next to that negative 3. Okay, we plugged in our value right here. So negative 15 combined with a positive 8, did y'all come up with negative 7? Hopefully. So when f of x value, x is 5, when you're solving this scenario and you plug in x is 5, the output is negative 7. In terms of graphing, like x and y, and by the way, the y value is traditionally the f of x, and the x value is the old-fashioned x. Okay? If I listed it as coordinates in the old-fashioned formula way, it would be 5, negative 7. Okay? And I could plug in other numbers too. I could say, what if x is 1? If x is 1, you're going to say, okay, negative 3 times 1 plus 8. This is the x value I've chosen. What if x is 1? And the result would be a positive 5. Okay? Exact same usage as the linear equations. Okay? So we're going to take this same thing. That was the first item. I'm going to list it again, and then we're going to read what they ask us the second time. They ask us something a little bit different. Okay? Same equation again. We're looking at B now, and they say, find x when f of x is negative 22. Find x when f of x is negative 22. Okay, so instead of giving us x, they've given us the output, the f of x, the y value, if you want to call it a y value. Okay? So the y value of negative 22, remember I've set up here, x is still x, but the usage of f of x is talking about what you've traditionally called the y. Okay? They give us this y value, this f of x value, and they plug it in here. Negative 22 is equal to negative 3x plus 8. How are we going to solve that? First step. Cat, go. She's right. So negative 30 is equal to negative 3x. Divide by negative 3. And x is what? 10. Positive or negative? Positive, because a negative times a negative is a positive. Okay? So the result is a 10. Put in a little chart which uses xy, or x and f of x. Remember, f of x is like the y value. It would be negative 22 in the f of x spot, which is the y, and 10 in the x spot. Okay? We're going to use the checkpoint a little bit. And they've given us an equation, g of x equals 4x minus 5. Okay, it's a little bit tricky. When you see it listed the way they do below, but I'm going to try and make it nice and clear. G of x when x is 2. Okay, so this is number 1. So g of x when x is 2. So they're telling us for checkpoint number 1 to plug in a 2 in the x position. Okay? They want g of x when x is 2. So I'm going to go g of x equals 4 times 2 minus 5, right? 4 times 2 minus 5? What's the result? 3 is correct. 2. G of negative 10. Okay. This and this are asking the same thing. Okay? Number 1 and number 2 are asking the same thing. In number 1, they list it kind of in an elementary way. But in number 2, this is more the method you will see it at. If they give you a function and they say find the g at negative 10, you're going to do what we did up here. G of x is equal to 4 times negative 10 minus 5. Okay? So number 1 and number 2 are plugging in and solving for your output. Negative 45, right, folks? Checkpoint 3. This is where they're going to give you a y value. Find x, or an f of x value, right? When g of x is 19. And by the way, f of x, g of x, q of x, zebra of x are simply ways to identify functions. Okay, if I am working with multiple functions, I need to know which one to use at which time. Okay, assuming I'm a scientist or I'm in Algebra 1, Algebra 2, you're going to use the g function for this and the f function for that. So then you're going to look. That's the g, That's the F. Okay, that's why you're seeing different letters preceding the names. Okay? Find the X value when the output is 19. Okay, so 19 equals 4x minus 5. Okay? We're going to add 5. 24. Sorry, I'm crushing it here into the bottom. X is equal to 6. Okay? That means when I have an output, a g of x, then the input must have been a 6. Okay? When I have an output of 19, the input must have been 6. Okay, you can graph these two just like what we've done already. Nothing new, guys. The terminology is the only thing that has changed here. So starting with example 2, we're going to graph these. And I still have those little tiny sheets of paper as you need them, and I have an unlimited supply. Okay? They want us to graph them. Step 1. Here's your function. F of x equals 3/4 x plus 1. Step 1, rewrite it in slope-intercept form. Y equals 3/4 x plus 1. Notice I replaced f of x with y. Okay? I replaced f of x with y. Now to graph it, I'm going to create a small chart here. My y-intercept is what? 1. My slope is 3/4, which means I go up or down 3. Up 3, right 4. 1, 2, 3, 4. Kind of sailing off into space here. Okay, after you have plugged in your points, always connect, because that tells me that you are aware that there are an infinite number of solutions that could be plugged in. Okay? Let's check point 5 and 6, please. 5 and 6. Checkpoint. First 5. It tells us to graph. Number 5 is g of x equals -3 halves x plus 3. Step 1, rewrite the equation, replacing g of x with y. Okay, repeat, repeat, repeat. Everybody see that? Replace the g of x, the f of x, the q of x with a y. And graph. My y-intercept is a what? 3. Positive or negative? Making sure you know that. Indeed, it's a positive 3. Okay? Up or down for the slope? Down 3, boom, boom, boom. Right, 1, 2. Remember, positive slopes go uphill from left to right. Negative slopes go downhill from left to right. That's a really quick way to always check to see if your graph is at least heading in the right direction. That's checkpoint 5. Checkpoint 6. Oh, look. H of x is -1. Step 1. Replace the function notation with a y. Y equals -1. That means x can be anything, but y is always down -1. Okay? -1. So yes, it is called a zero slope. Y equals 0x plus 1, if you want to think of it that way. Okay? That is a zero slope scenario. Okay, that's checkpoint 6. We're almost done, folks. 3 and 4. Example 3. What if you're given points And I'm telling them to you as points because remember how I said x and y are the same things as f or x, and in this case for number 3, g of x. Okay, remember how I said that? The letter of x is the output, the y value. The x is still the x. Example 3 says, write a function, a g function that is, g of x, that gives a value of 0, 9, g of 0, that means the value if you plug in 0 for x is 9, and 3, negative 6. Okay, so I took what they gave us, g at 0 is 9, g at 3 is negative 6, and I moved them into their appropriate old-fashioned columns, what I'm used to seeing. Okay? Do we have what you would think of as a y-intercept? Yes, sir. 9. Your b value is 9. Can we find slope? You bet. Change in y over change in x. 9 minus a negative 6 over, and I'm going to go down, 0 minus 3, which becomes 15 over negative 3, otherwise known as negative 5. Would you agree with me that I've done my arithmetic correctly? 9 plus 6 is 15, 0 minus 3 is negative 5. So my m is negative 5. So, if I write it in traditional slope-intercept form, it's y equals negative 5x plus 9, right? I have to mark you wrong, because that's not what they want. They want the function. Replace the y with the function they've told you. They want it as a g. Okay? So g of x equals negative 5x plus 9. Yes, sir?
When we'll be doing our work, when we're doing that, like, plus thing, which is the slope and the g of x value, do we have to label it twice, of like x and then g of x? So
yes. Oh, no, the x's and y's, I don't care about that. All I'm going to look for is that you translated the y to the function. Okay, I never do this. I'm only doing this to teach you guys that x is still x and g of x is like a y. That's the only reason I'm doing it. Okay, so you can absolutely create an equation based on 2 pairs of points, 2 pairs of inputs and outputs. Okay, sorry, I know this is going long, guys. I'm going to practice one with you. Okay, checkpoint 7. Okay, checkpoint 7, and this is all perfect examples for your homework. Write an equation. What kind of equation do you think they want for 7? F, Q, L, Z, F. So they're looking for an f of x equals something. Okay? And they've given us 2 pairs. X, and they've given us f of x. X is still x, which is 0, 2, 9. I just copied them. Okay, what they gave us was the f at 0 is 1. This is your x, this is your y. The f at 2 is 9. This is your x, this is your y. Now that I have that, do I have a y-intercept? Yes. Okay, plus 1. I'm kind of filling in the blanks as I go. I don't know if you see that's what I'm doing. Okay, I'm going to go down. 9 minus 1 over 2 minus 0. So 8 halves, 4. There's your slope. There's your equation. Okay? The x's are still the x, the first item in your coordinates. F of x is your y, the second item in your coordinates. Lastly, let's look at example 4. In the real world, you've already done this. When you guys did several examples in your homework, you figured out, even when you did the best fitting line, or the bamboo growth. If you remember the bamboo growth from a couple of days ago on page 420, this is the exact same thing, only they're calling it a function. Okay, after the balloon described on 426 was launched, it rose at a rate of 500 feet per minute to achieve a final altitude of 120,000 feet. So using function notation, they want us to write an equation. I'm sorry, guys. We'll pick this up tomorrow. Do what you can to get through 12 through 28.